Okay, so what is today going to be about? So up to now, we've been studying probability, and a lot of what we've been studying is ways to understand like how many different types of groups there are, or how is information laid out. And today we're going to be talking about the contingency table, or the two-way contingency table. And it's just a tool for organizing data, and especially when we want to determine whether two events, each with only two outcomes, so two events with only two outcomes, are dependent or independent. And the table helps us visualize the different subsets in the table and the different combinations. And normally what we do from the table is we try and work out whether the two events are independent of each other or not independent. The identities that we use, that we look at, basically, if we know that events are independent, we can use this formula, this placeholder. And if we're trying to prove that events are independent, then we need to show that this is actually true. Now, the A and B are just placeholders. They just represent events, and that will become a bit clearer to you throughout today. But my experience is, first of all, let's start with understanding how a table works. And the table is basically just the sample space for the question. So let's start with the table, and we'll go from there. So here is a table of data. And if we look at the two events, we basically have over here, we have the gender, right? And you could be a boy or a girl in this case. And then over here, we have favorite sport. And favorite sport actually has three outcomes. So you could be football, athletics, or other. And so in some ways, these are the two events that we're concentrating on. Now, I want to ask a few questions about the table. So can you start by giving me the answer to these four questions in the chat? Just by looking at the data in the table. And then you can pop them in the chat. And yeah, if you have a question, just raise your hand. Okay, you guys are on the money. Yep. So this is going to be 4. What's the most popular sport with boys? So we look at the boys row. And boys, the most popular sport is football. Okay, how many? Let's give you some time to do C and D. I'm gonna get some water and you can. So when we're trying to figure out how many girls in class, we actually just having, with tables, there isn't a total row here, but I think adding it in is quite useful. 5 plus 4 plus 7 is 16. And so we know that there are 16 girls in the class. Now, how many pupils are there in the class? That's what I want to know. Well, yeah, when we have tables, having a total column is quite important. So 2 plus 4 plus 1 is 15. And you know what? This should actually add up in both ways. So if this is 15 plus 16 is 31. So I agree this is 31. Okay, Level, let's make you co-host. Make co-host.
Thank you, Mr. Ace.
No worries. So if we look at this table now, what we have is we're also going to see that the total for football is 15, and the total for athletics is going to be 8, and the total for other is going to be 8. And so what we notice is 15 plus 8 plus 8 is going to be 31. So when we deal with contingency tables, it's always important to understand kind of what the information in the table means. And it's also important to have total columns, because the total columns allow us to understand the subgroups in the group. So let me ask you this question now. If I say to you, I'm choosing a random person from the class, and I want to know what is the probability that this randomly chosen person is a boy, and I'm going to use B for boy. Can you tell me what the probability that is using the data in the table? Okay, so you know that there were 31 people in this group, so that's the possibilities. And how many of them are boys? It's 15 out of 31. Okay, awesome. How about, what is the probability that somebody's favorite sport, so this is a slightly different question, is, let's say, the probability that someone's favorite sport is athletics. So I'm going to call this A for athletics. It's not like, what is the probability that a randomly chosen person's favorite sport is athletics? So I'll give some time for those answers to come through in the chat. So the total number of people in the group is still 31, but I've asked you about athletics. And so which number in the table is most helpful for you? I think it's going to be this number over here, which is 8. Those 8 people chose, there were 4 boys and 4 girls, but in total it was 8. So we get 8 over 31. Okay, now I'm going to ask you another question. What is the probability that a randomly chosen person from the group is a boy and has athletics as their favorite sport? So if you look at that table, I'm asking you, what is the probability that a randomly chosen person from this group is both a boy and has a favorite sport of athletics? So we know that the total is not going to change, but what group in the table is going to be relevant for this? It's not going to be the 8 down here. It's going to be this 4 over here, right? And so what we have is that the probability of this and this occurring, or B and A occurring, is just going to be 4 out of 31. Okay. So now, just give me a quick, I've been going quite quickly. I just want to get a quick thumbs up, thumbs down. If you feel like you followed how I've connected the table to probability calculations, give me a thumbs up. And if you feel a bit lost how I've connected the table to probability, give me a thumbs down. Just want a quick little check in. All right. Okay, so let's try and link something else now. One of the common questions in this section is trying to work out whether or not a common question might be, is gender independent of favorite sport? Right? So the 2 events, you can see the favorite sport up here is the green one and gender is the sort of red one. How would we, who wants to maybe have a go at explaining what calculation do we have to check whether or not these 2 are independent? There's actually all the information already on the board that you need, but I'm curious to know if anybody can make that connection. Otherwise, I will do it for you. So, Lesejo, yeah, what do we need to check to see if these 2 events are independent? Can you hear me, Lesego? I'm trying to unmute you, but it just keeps going. Oh, there we go.
Is that better?
Yeah, perfect.
Okay. So I think you would have to multiply the.
You're on the right track. Yep.
You'd have to multiply the probability of. You'd have to multiply the probability of, I think, gender versus the probability of the sport, and then see if that's equal to the probability of gender and sport coming together.
Okay, you're almost perfectly there. So let me show you. So you said gender. So the P of B is gender, right? It's boys. And the P of A is athletics, which is for the sport. Can you see that those two calculations are gender and sports? And then the one at the bottom is both gender and sport. So all we need to check is what is the probability of B. So it was, now we're going to do a couple of these today. So the first time you see this is a bit weird, but can everybody work out what is 15 over 31 times 8 over 31? Give me a decimal. I'll do it with you as we go. What are you guys getting for your decimal calculation there? You can pop it in the chat if you like. Yeah, so I get 0.12486. Okay, I could go on for a while. So that is the multiplication of the two. What is the probability of B and A or A and B? It's 4 divided by 31. And for that, we get 0.129032 and so on. So what I want to ask you now is, are these two the same? Like if you look at this amount over here, and you look at this amount over here, they're not the same, huh? And so because they're not the same, we'd say they're not independent. Now, that's just the first time I've done that. But if you look at the original thing that I was kind of asking about, you're looking at a gender question and then a favorite sport, and then you multiply them together to get a number. And then you compare it to the probability of both of them occurring. Now, I don't expect you to understand this perfectly now, but I just want you to understand the basic ideas. So give me a thumbs up if the basic logic makes sense, and you just need a bit more practice. Give me a thumbs down if you feel very confused. Just want to see kind of the spread in the house here. Okay, so because these numbers are not the same, they're not independent. If they were the same, they would be independent. That's the basic idea. Okay, so my promise to you is this will get easier the second time we do this. So let's move on to the second time we do this. So let's start with a nice table question. So over here, I want you to answer those first 4 questions for me. And I want you to think about what are the 2 events being considered. But yeah, first of all, can you answer 1, 2, 3, 4 for me? And yeah, if there are any questions, pop your hand up now. I'm happy to answer them. If anybody's feeling brave and you want some airtime, please, I'd love to hear your voice. I see Boy Tomelo is locked in an answer, and so is Mason. Well done. I think I agree. Brown hair would be, where's brown hair? So brown would be here, 17, and the total is 50. So we get 17 out of 50 for that. And for blonde hair, what's that going to be? Geez, the answers are flying in here.
They're on fire.
Okay, so I'm getting the impression that, you know, this is not too bad for you guys. So I'm going to put the answer in there, 11 out of 50. What about 3 and 4? What is the probability that a randomly chosen learner will have black hair or brown hair? And then, yeah, let's go to Lesejo. Lesejo, what's your question? Can we unmute Lesejo?
No. Oh, no, I don't have a question. You said if we want airtime. So I just,
okay.
For number 3, I got 39 out of 50. And for number 4, I got 50 out of 50. I'm not sure if that's correct, but I think. I got 20. Wait, so black hair would be 22 and brown hair would be 17. So I agree. You get 59 out of 50. And what did you get for the 4th one? 50 out of 50. I could be wrong.
Yeah, no, I agree with you, because it's, if you think about the collection, there's 50 students, right? And what's the probability they'll have black, brown, or blonde? Well, it's got to be one of the 3. So it's 50 out of 50 or 100% chance. Perfect. Yeah, great. Okay, so now if we look at this table, understanding the various groups in this table are not too difficult for you guys. I can see that you can extract the subgroups. But what if we wanted to think about in this question, is hair color, so here's hair color on the side here, is this independent of gender? So, you know, if I know someone's a girl, does it make them more likely to be a certain type of hair color versus boys or not? That's roughly the translation, but let's stick with the mathematics to be accurate. I'm going to ask you the following question. In this table, what is the probability that a randomly chosen person is a girl? And then I'm going to ask you to find what is the probability that a randomly chosen person has black hair. And I want you to work out that for me. And let's just see what you get for that. So what's the probability that a randomly chosen person is a girl in this group? And the sneaky thing is it's always going to be out of 50 because the sample space is 50. Okay, so I like what I'm seeing. I'm seeing a lot of people saying the probability of a randomly chosen person being a girl is 24 out of 50, which looks great. What's the probability of somebody having black hair if they're randomly chosen? So that is going to be the 22 over here. And so we get that. Okay, all's good so far. But now here's the problem. I want to show or try and show that hair color and gender are independent or not independent. And I need 3 bits of information. I'd love someone to come online and tell me what is the 3rd probability that I want to calculate that will help me with this calculation or help me with this. Now, there are other ways to do it, but I'm choosing the easiest. What do you think I need to, yeah, Kajejo, let's go to you.
Hello, sir, can you hear me?
Loud and clear, loud and clear. What do I need to find?
You need to find the probability of a girl who has black hair.
You are winning at life. I'm loving it. Okay, tell me what that probability is going to be in this question. If I look at the table, yeah.
It's gonna be 10 out of 50.
So you went
10
and found
over 50.
yeah. So you found the group of people who are girls and have black hair, and they're over here.
Yes.
10.
Mm-hmm.
Fantastic. Okay, now, if I want to tell if these two events are independent, what do I need to do next? Any ideas? Let's go to Lesego. Yeah, Lesego.
I have no confidence, but
I think I lost Lesego there, but
I think you
yeah.
have to
Okay, I'm losing you there, Lesego. I'm going to go.
Can you still hear me? Hello?
Hi. I think, okay, I think I got what you were saying. I think you were saying probability of girls. So 24 over 50 times by 22 over 50, right? And you said get that. And what am I going to be comparing that to? Leah Bonner, I'm going to come to you. Can you hear me, Leah Bonner?
Hello, sir.
Hey, what am I going to compare that to? Yeah.
You are going to compare it to probability of girls and black.
Okay. And I think the easiest way to do that is to put it into a decimal, right? So let's, because otherwise it's hard to compare when it's like this. So what do you get for 24 over 50 times 22 over 50?
I get 0.2112.
Yeah. And for G and black, it's just going to be 0.2. And because they're not the same, we say they're not independent. Yeah, because these are, I know that they're quite close, but they are still different. Okay, quick little thumbs up, thumbs down vote. Or if there are any questions. So thumbs up if you understand what I did to check that. In terms of actually saying they're not independent, you also give a reason. So you can say here, P of G times P of black is not equal to . So that's just the reason that you're showing that. Okay, so it's a bit of a mixture, but reasonably on the right track. If we keep doing this, I promise it'll become piece of cake. Sometimes what students also ask me is, did you have to use girls and black? And you didn't have to, but you have to be consistent. So if you had chosen, say, for example, girls and brown, then when you chose, so let me actually just show you this slight variation. So say, for example, you chose, instead of black, you chose brown. Then the and that you're looking for is also going to be girls and brown. So there are many ways to do it. I just chose the simplest one because girls and black were the first two outcomes in each event. But you can adapt it depending on the question. But I say just keep it simple. Yeah? Why make it more complicated than it needs to be? Okay, what I want to do now is we've been working hard for half an hour. And so what I want everybody to stand up and have a quick stretch. And Lebo, if you could help me by encouraging our students to just give themselves a break, treat their bodies nicely, and just
Come on, guys.
turn on
Please
those
join us in
cameras.
the stretch.
Show me
We
those
love
happy
to see your
faces.
faces.
Yes.
Give your mind and body a break.
To me, I know you want to. There we go. And
Shout out to Lesego. Shout out to Pechelo. Yes, guys, come on. Don't be shy.
I believe in you.
Yes,
And
shout
check
out
it
to
out.
Nell. Shout out to Shisana.
Oh, Doesn't that feel good? Oh, Lesego, I can see how happy you're looking right now, just because you're stretching over. Neo, same thing. You see, we think our bodies, guys, you have to treat your
Shout out
bodies
to
right.
Katlego. Shout out to Leah Bona. Loving this energy, guys.
It's like your brain wasn't made to do maths for continually. Like you need to kind of just shake it up. And then if you treat it nicely, it's like your car that you send for a service. If you treat it well, it will treat you well. Okay, let's do a quick brain break. So here is the brain break for today. It's a real classic. And I want to know who can answer this question for me. A bat and ball costs $1.10 or R1.10, doesn't matter. The bat costs $1 more than the ball. How much does the ball cost? Aha. So Rona has an answer. Shoshana. Okay, now here's the warning. Us maths teachers are a bit sneaky. What I would suggest is draw a picture. Just draw a picture to think about this question a little bit more deeply, because normally brain breaks always have a little bit of something else, a little bit of something extra. So why don't you draw yourself a bat? I'll draw a cricket bat. Oh, I'm not a very good artist, am I? And a ball. And you've told me that this ball is 10 cents. And if this bat is $1 more, I'm guessing it has to be $1.10. But now when I add them together, I get R1 or $1.20, which is not what they said at the beginning. And this has me puzzled. Perhaps there's more to this question than you first realize. Doing a drawing is always helpful. Who wants to put themselves on the line? Shoshana, I feel like you want to. What do you think? So give me a thumbs up if you understand why it can't be 10 cents. Give me a thumbs up if you understand why it can't be 10 cents. Okay, Fagelo, you understand? Why don't we try another amount? What other amount? Who wants to give us a tip? Or who wants to give us another guess? It's not 10 cents, because if it was 10 cents, it would get to 120. Sihawa, what do you think? Or Courtney, what do you? So this is actually a very famous problem. Lesego, yes. What do you think it's going to be?
Probably extremely wrong.
Doesn't matter. Pull the trigger.
It's free.
Free.
Yeah.
Okay.
Yeah, so
So
zero.
if it was free or 0 cents, the ball, this is going to be $1 more or R1 more. So this would be R1, and then together you'd have R1 in total. So it's somewhere between 0 and 10. Because it's too much if I make it 10 cents. It's too little if I make it 0 cents. Aha, Katlego, yes. Fagelo, yes. Do you want to explain how you got it, Katlego? Well done. You could make an equation, yes. That is no joke. Okay, so this was just a fun little exercise, but basically you can see this is correct because this is 5 cents, and what's more than, or if a bat costs $1 more than the ball, it will be $1.05. And if you add $1.05 plus 5 cents, what do you get? You get $1.10. Okay, so that is just a bit of a brain bender. Just give me a thumbs up if you understand the answer now that I've given. Rona, I will do my best to provide you with another one in the next lesson. This is a very famous one. Okay. It's an example of something where you really have to slow yourself down and read the question. But for today, our goal is to talk about probability. But I hope that it spiced up your life a little bit. That was my intention. Okay, cool. Okay, so before we go back to the work, just one more little shake it out. Just shake out those hands, stand up if you need to, because we're going into part 2 of our lesson now. Okay, so here is I'm going to give you you can do this whole question by yourself now. And this is a typical exam question. It's a two-way table, and over to you. You've got 3 minutes. The clock starts now. Turn those cameras on if you can, just so we can see your hardworking faces. And those answers are flying in. I love it. So for A, seems like everybody is feeling very confident. Female, 50 out of 80. Yeah. And then play sport. What column is going to be relevant here? Play sport is this column here. And so that is going to be 48. So I want to know who is, once you've finished A, B, C, D, E, who wants to tell me their answer? Who wants to see if they know whether or not sports preference is independent of gender? So female and play sport, that is going to be 21 out of 80. And let me write that as a decimal just to start with. And then D is going to be who thinks they can answer E? Who would like to have a crack at E? Yeah. Maseko, what do you think?
I think preferences are not independent of gender, because
Yeah.
the probabilities of someone being a female and playing sport is not equal to the probability of someone being a female multiplied by the probability of someone playing sport.
So do you have a number for 50 over 80 times 48 over 80?
My number for is 0.38, I believe. Yes, 0.38.
0.375. Yeah.
Yeah.
So I agree. So it's not independent. And the reason is that basically P of F times the probability of playing sport like this is not equal to the probability of F and S. Or in terms of the numbers, it's going to be 50. It's basically this stuff up here. Does not equal to this one over here, which is 21 over 80. So that's normally, you give one of those two things as a reason. I just want another quick little check to see if you're following my method. The thumbs up if you understand how we check that, thumbs down if you feel a bit lost. Just want to check the chat for a second. The good news about this process is it's very predictable. So as long as you understand what the different parts of the table mean, and you can apply this method, checking whether or not they're independent or not is fairly straightforward. But you just need practice of more examples. So we'll do some more now. Are there any questions before I carry on? Or anything you want to clarify? Okay. Well, then let's go to a different type of question. Let's have a look at, let's see if I go. Let's do this one first, and then we'll go to the other one above that.
Mr. Hayes?
Yeah.
Sorry, Mr. Hayes, can you take a question from Katlego?
I can, yeah. Let's do it.
Hi,
So while
sir,
I'm
how are
taking the
you?
question, very good, man. What can I?
The question is that since you said the events are not independent, does it make them dependent?
Okay, so I would say that there's a bit of debate about this. Can I just say go with not independent? That's what I've seen. When I mark matric exams, they do prefer that as opposed to dependent. So I know it's sort of a bit of a language debate, but I'm going to say, rather say if they're independent, it's one thing. Otherwise, they're not independent. That's what I'm going to say is the preferred terminology that I've seen. Okay.
So if I say they are dependent, I get a 0.
I wouldn't say it depends on the teacher. I'm just saying that my preference would be to say not independent. Okay, I can't give you 100%. You will sometimes get the mark, but all I can say to you is my professional judgment says rather say not independent.
Okay, thank you.
Pleasure. Okay, let's try and do question 2 here. And over to you guys. And girls. So while we're working on 2.1, before you answer 2.2, I want you to think about what information is missing. Okay, when you think about 2.2, and if you know what's missing, maybe put your hand up so you can tell me. For now, female and play tennis is going to be 20 out of 50. Oh, 150, sorry. I'm really curious. So in 2.2, it says, is playing tennis independent of gender? So here's the event of playing tennis, not playing tennis, and here is my gender. Now, what I want to know is, I've only got 2 bits of information. What is the third bit of information I need to calculate to help me understand whether they're independent or not? Could somebody possibly point me in the right direction? What key bit of information is missing? Maybe if I said, okay, well, I know I worked out what that was, and I worked out what that was. What do I still need to work out to help me with this independence calculation? Yeah, Nadi, let's go to you.
I think you're supposed to get the probability of females multiplied by the probability of females playing tennis.
Okay. Okay, so you're almost there. So the probability of females, I'm completely with you. And we do need the probability of females, or probability that somebody chosen is a female and play tennis. But there's 1/3 bit that's still missing. Okay, Leah Bonner, yeah. Let's go to you.
We have to find the probability of people that play tennis.
Yeah, so the probability that a randomly chosen person in this group plays tennis. Do you know what that's going to be from the table?
Let me calculate that.
Awesome. Who knows what the answer to that's going to be? So the probability that a randomly chosen person plays tennis is just going to be 70 over 150. I'll go to the column with playing tennis, and I see there's 20 females and there's 50 males who play tennis. Okay, now what I need to do is I need to compare. So I take basically the probability of F times the probability of T, which is going to be that. And then I also want to know what that is. And the easiest way to do that is going to be to use it as a decimal. And let's see, are they independent? So what do you get for this first bit here? I get 0.21777 recurring, or 7778, or 0.22 if we're rounding off. And then 20 divided by 150 is going to be what in decimal? So I just think it's going to be 0.133 recurring. Okay, so are these 2 events independent? Yes or no? What do you think, guys and girls? No, yeah, they're not independent. Awesome. So you can see it's a very structured method that we apply. And yeah, as long as you stay consistent, should be easy marks in the bag. So have you guys got enough energy for one more question? Thumbs up if you think you got one more, or maybe thumbs down if you're like, okay, I want to just download this. Let's get a sense of the group. Okay, I see some people who cannot be stopped. Okay, let me look for a, let's have a look. It's a bit too many questions, I think, for the last bit here. Let's just try, let's just do this one over here. And we may not finish the whole question, but we'll try and get close to that now. And there's a couple of other sneaky things in here. Let me see if I can get that to scroll up. Okay, over to you guys and girls. Calculate for me the values of A and B to start with, and try and see if you can. Now, we haven't used the word mutually exclusive for a while, but I'll see if you can remember what that means. So I want you to try and do these two questions for me. Notice how it's a slightly different type of question where the table is not completely filled in for you. So it says in the question, there's 100 boys and 60 girls who are being surveyed, and we're comparing gender versus whether they watch TV during exams. For me, B is the simplest one to find because it looks to me like I should just go 80 plus 48. So 128. And if I know that male is 80, then this should be 20, which means that's 100, and that is 60. Awesome. Okay, so that was 2 marks in the bag. Awesome, awesome. So even if they leave out some of the totals in a table, you can just fill them in. So now they're asking a slightly different question. Are the events being male and did not watch TV during the examinations mutually exclusive? I'd love someone to come online to give me their interpretation of this, because there's different events, but it's a slightly different type of question to what we've dealt with earlier. Yeah, Leah Bonner.
So I think the 2 events are not mutually exclusive
Okay, and what is your reason?
because being male and did not watch TV is not equal to 0.
Oh, you are so good. Exactly. So there's a group over here. Can you see there's 20 students who are male and did not watch TV during examinations. Now, if 2 events, or if things are mutually exclusive, it means that you can't, they have basically an empty intersection. So basically you would say male and did not watch TV. So I'll just say TV dash, which means did not watch TV. This would have to be equal to empty or 0. But you can see over here that there are 20 people in that collection. And so these are not mutually exclusive. So it's basically because this is not equal to 0. Another way of saying it would be to say there's a non-empty intersection. Figuelo, you also got it completely right. things are mutually exclusive if the moment you're in one set, you can't be in the other. But in this case, you can definitely be a male and not watch TV during an examination. In fact, there are 20 males who didn't watch TV during the examination, and they are hiding out over here. Just give me a thumbs up if you understand that. Mutually exclusive is different wording to independent. Okay, cool. All right, so then last two questions of the day. Last two questions. What about these two? 1.3.1, 1.3.2. So what's the probability that a randomly chosen person watched TV Okay, so what I'm seeing in the answers is you've all figured out that the correct is 128. They watch TV during examinations, and so the probability would just be 128 out of 160. Yeah, 128 out of 160. Okay, what is the probability that a randomly chosen person is not male and did not watch TV in the period during which examinations were written? So the not male part is code for what? It's code for female. And did not watch TV during the examination. So what's that going to be? Who wants to end us off tonight with the right answer? Who wants to come on and give us an audible answer there? Yeah, Leobona, let's go to you. What do you think the answer is? Can you hear me, Leobona?
So I think that the answer will be 12.
Yes.
Or over 160.
Exactly. It's going to be 12 over 160. That's going to be the correct answer. Okay, can everybody see? So if we're looking for female, we're looking for this row over here and did not watch during examinations, and did not watch is going to be over here. So that's why it's 12. And then the total is out of 160. All right, people, that is the lesson for tonight. In the next lesson, what we're going to do is we're going to look at the types of questions where we have lots of identities intermingled. You write, see how, if you want it in the simplest form, you could write it as 3 over 40, or you could write it as a decimal. It just depends on what the question says in terms of specific. Anyway, so the next lesson, we will look at examination questions that involve all the different types of identities, but I'm pretty happy with what I saw tonight. And so, yeah, hope you enjoyed it too.